Let's see question number 5. In this figure, DE is parallel to OQ. DE is, this line is parallel to OQ. DF is parallel to OR. DF is, this line DF is parallel to OR. Show that EF is parallel to QR. So we have to show that EF is parallel to QR here. Now in this exercise we still have 5 more questions. The question is up to question number 10. Now in all the questions we are going to apply the basic proportionality theorem, which I have already learned. Now the basic proportionality theorem says if a line is drawn parallel to one side of a triangle, then the other two sides are divided in the same ratio. Now this line and this line, if they are parallel, if this line is drawn parallel to this line, then the ratio here AD by DB is equal to AE by EC. AE by EC. Now this we can write only when these two lines are parallel. If they are not parallel, then this is not true. Now the converse of this theorem is, the converse is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side here. Now here in the converse, if the ratio of, let's say this is DE, if the ratio of AD and DB is equal to the ratio of AE and EC, that is if AD by DB is equal to AE by EC, then what happen is these two lines are parallel. This DE is parallel to BC. So this is the reverse of the basic proportionality theorem. So this is converse of PPT, basic proportionality theorem. So these are the two properties that we're going to use in all the question. So let's see the first one here. To show is EF parallel to QR, and solution. Now first let's take this triangle PQO, this triangle. Now in this triangle it is given that DE is parallel to QO, OQ. DE is parallel to OQ. Now since these two lines are parallel, BE by EQ will be equal to PT by DO. So here in triangle PQO, DE is parallel to QO. This is given. Now therefore PE by EQ is equal to PT by DO. PT by DO. This is basic proportionality theorem. This is by basic proportionality theorem. Now let's call this 1. And again we're going to take the other side triangle, this triangle. Now here again in this triangle, this DF is parallel to OR. So we will have BD by DO is equal to BF by PF by PR. In triangle POR, DF is parallel to OR. This is given in the question. Since it is given, therefore df by pt by do will be equal to pf by fr. pf by fr. This is by basic proportionality theorem. Now let's call this 2. Now from 1 and 2 we get, from 1 and 2 we get, now from this 1 and 2, P by EQ is equal to BT by DO. Again the same BT by DO is equal to PF by FR. So that means these two are equal, this one and this one, because here if x is equal to A and again x is equal to B, then A will be equal to B. So PE by EQ is equal to PF by FR. Now thus in triangle PQR, now let's consider this whole triangle PQR. Now let's look at this big triangle PQR. Now in this big triangle, now let me throw here, this is our big triangle now, PQR, and E and F, this is E, this is F. Now this is the big triangle PQR. Now what we got here is PE by EQ is equal to PF by FR. PE by EQ is equal to PF by FR. So since the ratio of PE and EQ is equal to the ratio of PF by FR, then these two lines are parallel. That is the converse of basic proportionality theorem. So we're going to say that one, since thus in triangle PQR, PE by EQ is equal to PF by FR, which is shown above here. So this implies that EF is parallel to QR. This is by converse of basic proportionality theorem. By converse of basic proportionality theorem. Basic proportionality theorem. Now let's move on to the next question. Question number 6. Now in this figure, A, B, and C are points on OP, OQ, and OR respectively, such that AB is parallel to PQ, AB line here, parallel to this. AC parallel to PR, AC line parallel to PR, respectively, PR. Show that BC is parallel to QR. Now we have to show that this BC is parallel to QR. So here also in the same way we are going to prove it. Now here to show is BC parallel to QR. Now solution. First let us take this triangle PQO, this triangle. I'm going to take this triangle. Now in this triangle, according to question, this AB line is parallel to PQ. So we can say that OA by AB is equal to OB by BQ. So in triangle OPQ, in this triangle AB is parallel to PQ, which is given here. This is given. Therefore, OA by AB is equal to OB by BQ. OB by BQ. This is basic proportionality theorem. Let's call this 1. Again, let's take this other side triangle. This triangle OPR. This triangle. Now in this triangle, again we have AC parallel to AC, this line parallel to PR. So we are considering this triangle. In triangle OPR, AC is parallel to PR. AC is parallel to PR. This is given here in the question. This is given. Now, since these two lines are parallel, now we can say OA by AB is equal to OC by CR. OA by AB is equal to OC by CR. Basic proportionality theorem. So therefore OA by AB is equal to OC by CR. This is by basic proportionality theorem. Basic proportionality theorem. Let's call this 2. So here from 1 and 2, again from 1 and 2 we get, now here OA by AB is equal to this, and the same OA by AB is equal to this. Now this left hand side is one and the same, OA by AB, so this two will be equal here. So OB by BQ is equal to OC by CR. Now, so what we finally got here is, in this triangle, now we are getting OB by BQ is equal to OC by CR. So this implies that these two lines are parallel. This by converse of basic proportionality theorem. So let's write this in triangle OQR. This in triangle OQR in this triangle. OB by BQ is equal to OC by CR. So this implies that BC is parallel to QR. This is by converse of basic proportionality theorem. So that is what we have to show.